discuss the Big Bang Theory and Hubble's law. And for that, we need to talk about the theory of the expanding universe and the Big Bang Theory. So I would recommend you to watch some videos on that. But to explain it in the most simplistic way, we can say that the universe started with a very single point, and that single point had a very dense mass and hot mass, and there was a massive explosion that expanded the universe until today. Okay, so we need an evidence to prove our theory. So the evidence can be presented in the CMB radiation or the cosmic microwave background radiation. Okay, so this is type of an electromagnetic radiation that was a remnant of that massive explosion that happened in the early stages of the universe. And now it became a microwave radiation as it expanded. Now its wavelength has been stretching for so long, it has a 1 mm wavelength of the microwave radiation. And now we call it the cosmic microwave background radiation. So it was discovered in 1965 by two American astronomers that was looking for radio signals using a radio telescope. And they detected this signal coming from all directions, and it was not impossible to attribute this type of signal coming from one specific source. And later on they found that this signal had a very weak intensity and it came from all directions in the universe. And then this discovery was made that this is a radiation that's coming from the background and it's coming from the cosmos, and we call it the cosmic microwave background radiation as it comes from all directions. Generally, it has a very low temperature of 2.73 Kelvin. So if we look at the temperature at the early age of this microwave radiation, we will know that the temperature was really high in the beginning as the massive explosion occurred, and the wavelength was very small. As the universe kept expanding, this hot, dense environment started cooling down because of the expansion of the universe, and this created a redshift where the wave of the radiation became longer, so had a longer wavelength and also lower temperature to around 3 Kelvin. Yeah, and now it's in the spectrum of microwave radiation. We believe initially it was more in the gamma spectrum at the end of the radiation spectrum. As the universe kept cooling down and expanding, this wave became more stretched and more redshifted to a milder, cooler radiation. Yeah. So let's look at some reference for the wavelength and radiation chart. Initially, we said this radiation was probably in the gamma region, on the edge of the spectrum, with very high frequency and very short wavelength. But with the expansion of the universe and the stretching of the wavelength, it became now in the microwave region with a lower frequency and also longer wavelength. Yeah. So another theory that came and proved the expansion of the universe was Hubble, and Hubble showed through calculation that the universe is also expanding, which agrees with our cosmic background theory. So he proved it using an observation of the light coming from the distant galaxies, yeah, and the absorption line spectra that came from distant galaxies, and those spectrum of light was shifted towards the red region of the spectrum, yeah, and that was due to the Doppler shift as the wavelength was being stretched from the distant galaxies as they are moving away from Earth, yeah. So the observation from light, Hubble's experiment or Hubble's observation explained that any distant galaxy is being shifted further away from us will have a more red shift than the other galaxies that are closer to us. So if we look at the spectrum, the standard spectrum in the lab, the reference, we can compare it to the distant galaxies. We can see that this point here has been moved to the red side of the spectrum, which means it has been shifted to the red side as a distant galaxy. And if you compare it to a nearby star in our solar system, then you can see that that red shift is not as much from this part to this part, is not as much of a shift. Yeah. And then Hubble created his own law, Hubble's law, and he was trying to find the recessional velocity of the certain galaxy in proportion to its distance from the Earth. So he used this formula to find the constant that he called Hubble's constant, which is the velocity divided by the distance. Yeah. So Hubble constant has an accepted value of 2.2 10 to the power of negative 18 per second. So the distance is measured using MPC, and that MPC value is basically megaparsecond, which is a measurement of distance equal to 3.26 million light years. Yeah, and if you solve for the Hubble constant, you can define it as 2.2 10 to the power of negative 18 per second. Yeah, so this is the ratio between the speed of a galaxy moving away from the Earth and the distance of that galaxy relative to the Earth. Okay, so now let's look at another slide that talks about Hubble constant as well. Calculate and find the age of the universe. We can rearrange this formula using the Hubble's constant formula to solve for 1 over the constant, or the reciprocal of Hubble's constant, and that 1 over Hubble's constant will represent an estimate of the age of the universe. That gives us an evidence of how long the massive explosion happened, or what was the date for the Big Bang theory, the initial start of the whole universe. Yeah. So to find the Hubble constant, you can plot a graph of all the recession velocities and relative to the distances of different stars and galaxies from Earth, and then plot those points on one single graph where you put the recession velocity on the y-axis and the distance on the x-axis, and then you can plot a best fit line that goes through the origin, and that best fit line will give you the Hubble's constant. Yeah, this ratio is the Hubble constant, because we're dividing the recession velocity by the distance. Yeah, and then if you calculate the inverse of that gradient, you will get the time estimated in seconds of how many billion years the universe was created, or the birth of the universe. So the astronomers have used this formula and estimated the age of the universe to be 13.7 billion years using the reciprocal of Hubble's constant. And then this would prove that the universe started with a single explosion, and that proves the Big Bang theory and also dates the universe to a single start or a single point.